Hey, what is up everybody? It's the AI Wizard Show, and the following is my conversation with Connor Shorten, where we're gonna be chatting about GANs, which are generative adversarial networks. Also, we're gonna talk about deep learning on graphs and why that's both exciting and important, as well as different convolutional neural network architectures. And we're also gonna chat about Connor's YouTube channel called Henry AI Labs, where he breaks down deep learning papers in a really interesting and informative manner. So if you're interested in getting better with understanding the theoretical aspects of GANs, different architectures, deep learning down on videos, definitely check out Connor's YouTube channel. Also, you can find the timestamps to this podcast in the description, so if you want to jump to a specific part of the conversation, you can do that there. And you can also give this podcast a listen wherever you get your podcast, like on Spotify, iTunes, Pocket Cast, Stitcher. I'll leave some of the links in the description, or you can just type the AI Wizard Show and find the podcast. So I hope you guys enjoy this episode. Hey, what is up everybody? It's the AI Wizard Show, and I have my name is Ivan, and I have Connor Shorten here with me. We're ready to chat about a lot of exciting things. So why don't you say hi, introduce yourself a little bit.
Alright, my name is Connor Shorten. I'm a PhD student at Florida Atlantic. I'm studying artificial intelligence and trying to make YouTube video tutorials on some of the research papers to make it a little maybe easier to understand for somebody who's just looking at a new topic like ResNets or maybe like graphs, deep learning. It's kind of the idea that I'm trying to pursue, so I'm happy to talk to you about this.
Yeah, so one thing that specifically stood out to me and that I would like to dive right in is GANs, generative adversarial networks, and you've been doing a lot of videos about them. I myself understand just the basic idea, so I guess my first question would be is how would you define a GAN in terms of what it does and what it is?
I think anecdotally it's described well with the example of the cop and the counterfeiter, where the counterfeiter is trying to produce fake money and the cop is either responding that he accepts the money or this is fake money. But you'd imagine that the game is more rather than the cop catching him with the fake money and just locking him away and that being the end of the game, if the cop is instead here's your feedback for maybe how you could get me next time. That's sort of how I would describe it quickly. But then I think that once you start getting into studying it, the problems with it, that framework is nice, but I'd say the problems are sort of different from that. It's things like catastrophic forgetting and the continual learning problem in deep learning is especially pronunciated in the GAN framework, because the discriminator is trying to learn a decision boundary on the generator and is changing its parameters, and that's something that deep neural networks really struggle to handle well. And then another interesting thing is how different GAN models handle different target resolutions. Trying to generate CFAR 10 32 by 32 images is sort of easy depending on the class you're after. Airplanes would be easier to do than cats or dogs. But then if you try to scale that up to 512 by 512, I think it does seem like computation is mostly what stops you from doing that, but still it becomes a much harder problem. And so that's sort of something I'm interested in, is trying to figure out how to make it easier to generate high resolution images.
So I guess but what's the problem there? I would ask myself, I guess, and you, if you can generate, say, 50 by 50 pixel images, what's the hard part of scaling, the whole thing up to, higher res?
I think it's mostly a matter of, it's harder to optimize the generator with the discriminator because there are so many, flaws in the generator's output that will make it easy for the discriminator to classify it. How if you have any image data set and any classifier, it's going to do better with a high resolution input. If you're just classifying cats versus dogs, if you have high resolution images, it's going to do a better job than low resolution images. So I think it's on the discriminator end that makes it so challenging. But one other idea that could be interesting is to have these multi-resolution models where you have like,
and here, like, am I understanding this correctly, that the more pixels the generator like has to generate, the more kind of like ways it has to screw up, and for the discriminator to like figure out that like, hey man, like you did wrong there.
Yeah. It's just too easy for it. And then it'd be like if when I give my fake money to the cop is just like, this money's terrible, and he doesn't give me anything productive to make better money with. So it's
just because the money was like so like obviously bad, right?
Right. Yeah, exactly. So that's sort of what's been interesting me with that. And then I'm interested in seeing this, like, one of the big advances in GANs was this idea of putting the self-attention layer, like the attention layer from the machine translation, to bring that into the intermediate convolutional upsampling layers in the generator. So I think that's another really powerful idea.
And could you extrapolate a bit on what that layer and like what it does and why is it there?
I could explain it well in the context of machine translation, where you have a sequence of words and then you're encoding it into like a vector for the sake. It's like an autoencoder where you just take data and then put it in a low-dimensional representation such that it can reconstruct the original data. So the machine translation, it keeps, as it processes each word in the sequence, it constructs this vector to be decoded later on. But the idea of attention is like, instead of throwing away each intermediate encoding, you have another vector which knows which keeps all the intermediate encoding states and looks at like different series of the encoding, if that makes sense.
But what are we trying to like encode in the context of GANs? Like, what are we trying to do with that?
Oh, in the context of GANs, yeah, that's kind of why I've been interested in it. Is like, this is also how they do. I don't think it's the state of the art, but they've shown how this works for like image captioning too. Like, if you give me an image and I tell you like the guy sitting on the park or whatever. So I think it just works on its own internal representations. But anyway, that's something I'd have to.
I guess that's a little bit of like deeper concepts of what's going on there. So would have to like spend more time there. But like, when it comes to GANs, like, what are the applications in like the real world that kind of excite you, that make you want to like work with them and study them and eventually like share the info on your channel?
Well, I think generally it's apparent that it's going to have a big impact on like our art and our sort of all sorts of the media that we're creating, like things like television and, you know, like these animations. I think it won't be long before it can work on videos as well, because I've seen like the UC Berkeley paper, the Everybody Dance Now paper. That's pretty interesting. And so I think if you give GANs like maybe like 10 years even, that it wouldn't be like unreasonable to generate like an episode of a TV show. That's how far I think it'll come along, especially because it's in tangent with these other things like the OpenAI GPT-2, and then like I don't know the company, I think it's called like Lyrebird, but they'll take your text and they'll do text to speech, but they can do it in like your voice. So I think all these things coming together is going to be pretty exciting, and I guess that's what's drawn me towards GANs originally. Yeah. I heard about that thing that can reproduce your voice, and now as you're kind of like becoming a little bit like of an like OG, you know, like getting experience with GANs, like what are those things that excited you before maybe shift somewhere, or are they like get proven with time? Like what gets you excited currently? About GANs? Well, I've sort of, GANs is actually, like, studying GANs has led me to be more interested in reinforcement learning, because I suspect that it's the kind of dynamic of the generator in the environment, sort of, like in a similar way that if we were playing, like, chess against each other, and you'd consider you to be my adversary. I think that's, like, sort of the right way to look at GANs, right? I'm not sure, but that's sort of where I'm going with my own research in the future.
So you kind of like mechanics of like what's going on with the discriminator, like the cop trying to catch the criminal, and this kind of game that like keeps going on and on and on. There are like a lot of types of GANs, you know. I've been currently able to just understand like the basic idea of what's going on there, but there are like style GANs, there are like deep convolutional GANs. I've seen videos on your channel. Could you explain a little bit of like what are the like main differences, like, or not differences, but like what are like their unique, you know, ways they work?
Well, I'd say I would recommend first understanding the deep convolutional GAN, because it's just the idea of adding upsampling, like it's just the idea of adding convolutional layers to the GAN framework, which is pretty intuitive, easy to implement. It's got some other things like these guidelines of like batch normalization, like leaky rate, but it's all like kind of like black box. You don't really need to wrap your head all the way around all that. But the paper also introduces things like the latent space interpolation. Like the GAN will generate like a guy with sunglasses, and you can like control that input vector to change what this guy looks like. And that's you know, taken to a much higher level is style GAN. Style GAN will like take that to the next level and like really blow your mind with what it can do. But so it introduces that idea. But then what I'd say, in addition to the DC GAN, I'd learn what the conditional GAN is, because this is like how it actually works. Like, there are some papers on making GANs work unsupervised without labels, but it really doesn't work. That's like the Google AI, like cutting edge stuff to try and make that work. So once you understand like how the class labels work, then so once you understand DC GANs,
and am I understanding this correctly that kind of like if you want to have again like learn what a guy with sunglasses say look like, you gotta give it a label, yes? Kind of like that this is a guy and he wears sunglasses, and then I'll figure out that like that set of pixels is sunglasses. Or
I don't want to say you have to do that, but it makes it a lot easier if you do it like that.
And you mean that like that cutting edge unsupervised learning that's capable of that is kind of like the Google level right now?
Trying to make GANs totally unsupervised. Yeah. If you can do GANs without class labels, that would be pretty impressive, especially at high resolutions and with the diversity within the classes.
But like, what would like an unsupervised GAN like would be like able to do? Would it, you know, like, why would we try to make it unsupervised, I guess, is the question here.
I think mostly because they have like enormous data sets that are unlabeled. Like they have this like or they're noisy. Like the JFT data set is the biggest one that I know of that is like noisy and somewhat like weakly annotated is how they describe it. So I guess like you could say that just more data equals better, you know, results. But I don't know if I really like that idea. I don't really think of it in that way. But I think in the current state of the art, that seems to be the case. With more data.
And like ideally that system would be able to just look at a bunch of images and kind of learn not only how to like generate them, but what kind of like the inputs for each generated image are. Is that like correct? Like it will learn that that's the guy wearing sunglasses, and that's how like that's who it is, and that's also how to generate one. Is that kind of like what could be the purpose of it? I guess one question that kind of came to my mind is like we can generate a bunch of images, like and that kind of sounds like a useful thing for classifiers, for like CNNs that classify things. So I guess can GANs be used to augment data sets?
In my master's thesis research, I looked into this a lot. Like I tried to take the output of the GAN and just, you know, concatenate it to the data set and make it like double the size of the data set. But that actually doesn't work. And also doing things like trying to pre-train it. Pre-training kind of works, but it's unclear. Like, so I got pre-training. I was pre-training with the GAN and the real data, sort of like an initialization scheme, and then refining it on the real data only. But when I switched it from like a VGG style network to like a ResNet or a DenseNet, it no longer was working. So I can't say that this generalizes it. And so I have yet to find a way that you can use GAN data for data augmentation. But I think it will be figured out. But I personally have tried and failed.
And when you say you fail, you mean like you learn some weights with the GAN and then try to like use those weights to then train a classifier on them?
Oh no, that's a different idea. That's a good idea. That actually does work if you have like if you have no labels. You know that like that would be like unsupervised feature learning with the GANs. But I thought you meant just like train a GAN to generate data and then use that data to build a classifier for your original problem. So that doesn't work. The other thing works.
So we can. I mean, but could that like work in the future? Maybe, like augmenting the data sets.
Yeah, I've seen it. Of augmented data sets. I really don't understand why it doesn't work already. So I can't say that. I have no idea why it should work.
Yeah,
it doesn't, but it looks like it should.
One more thing to figure out for folks like you, I guess. And maybe me in some direction. So I mean, were like there any projects that you built that were using like GANs already that are kind of cool and you'd like to share? Like or say like generated images or something.
I'm not sure where it's really going to go. And I don't know if I really think about it all that often, but I mean, I think just generally it'll be like even things like as innocuous as like your little logo design for like some company, it could do that. Given like it's really just like if you give it a ton of data, it'll generate more data. So it's like have at it whatever you think that might be useful for. But it's an interesting problem to see, at least.
And like for now we've been like talking about what GANs like can do, and we've talked about that they aren't like really for now working to generate data. Are there like any other domains where GANs are kind of like failing to maybe do their job, where we maybe would be wanting like them too?
I think the most exciting one is like structuring data as graphs and then using the GANs on the graphs to do like chemical compound synthesis. But it's something that I've seen, like I'm familiar with this idea, but it's not something that I could like get into the details of and explain exactly. I've just recently been looking at things like deep walk and like graph convolutional networks to see how deep learning operates on the graph domain, because it's like these. It is pretty interesting though. The more I look into it,
and like graphs, and like this is kind of what, and then this question, like this is kind of what people use to like fold proteins and that sort of thing, like with chemistry, yeah. So like that's kind of why I would be interested in that in the first place. Okay, so what's happening there?
With the AlphaFold from DeepMind, the way that I understand it is that. They can use like the graph, the topological structure of it in these like GCNs and stuff as like the sensing mechanism, sort of. It's like how they interpret the environment in that, like, the classic RL framework where it's like agent sends reward to or like environment sends reward to agent sends action. I think it's just like the way that the agent perceives the environment or something. I'm not really totally sure about how that specifically works, because that's probably like above my level. but yeah, it's just generally interesting, the idea of like using topology in your like data analysis, because it can give it more. I just like the idea of like heterogeneous senses. So it's like it can have vision, language, like speech, and then you also combine it like this topological information. I just think it's interesting to give like I think an AGI system would have a lot of different like sensing modalities. I don't think it would just be like a vision system. So like a GAN, I think that you would call like intelligent. This GAN is intelligent. I think it can understand other senses. I think that's an important component.
When it comes to like being able to like learn on graphs or like in the like in what domain is that especially intelligent, in which you're like talking about? Yeah, I mean like in which domain is the net intelligent? You mean like the regular GAN or the one that's used for or on like graphs? Like
right. I'm not sure. I guess depends on your definition of it. like your taxonomy of the difficulty of tasks is how I come to think of it. Of like just intelligence, not like consciousness, just intelligence.
But and about like learning on graphs, you've mentioned before to me that this is kind of the topic that you've been also getting into. And what were the inspiration to like start learning about deep learning on graphs, and what do you think you would like to study with that and then do with that in the future?
Well, as I've started to try and make YouTube videos and try to like connect with and maybe produce something of value, it's sort of interesting to think of these social networks. That's sort of the place that I started being interested in graphs, because like it's very interesting to see how like there are these nodes like Siraj Raval and like Lex Friedman who are like they're it's just like the connectivity of the people who follow them, and like kind of analyzing these structures is really interesting. And then so past that, another thing I've been interested in is these citation networks, where it's like, if I write a research paper and you cite my research paper, there would be an edge from my paper to yours. And it's like, you could think of it as like a new way to understand like how science develops, like how the research is published and like how it all relates to each other, how this like publication network evolves I think would give us a better sense of the future.
Oh, that sounds like really interesting. I just kind of tried to imagine that, but like the interesting part here is that like this is all data already, like this whole interconnected thing, and like being able to use a neural net to say like wrap its little digital mind, or maybe not little, around like the whole grid, like whole set of like connections different between like followers in social media and citations in science. Do you see, and like a neural net is able to do that, but what may then come out of that? Like, what could be the potential application of its being able to like wrap its mind on the graphs around like what's going on?
Well, I think it'll generally give us a better way to organize these social networks, like things like the Twitter algorithm, how the news feed is organized, and all these platforms have this news feed sort of, and they have like suggestions, like link prediction and like just recommendation engines generally. I think is going to be a huge component of how these massive software systems like evolve, especially like with Amazon. I think that I read this book where it's like the economics of artificial intelligence, and he predicts that he thinks that Amazon will be so good at predicting what you want to buy that it'll just ship it to you and you'll just return it and you'll be like, oh, you got this one wrong, but it'll happen so rarely. And that's what he predicts in his book. And I thought that was far fetched, but I think that the development of graph neural networks is what will power that kind of thing.
And what are like the things that you are focused on like working and studying currently?
Currently, I'm mostly trying to get a better sense of reinforcement learning. It's something that I've like maybe, unlike the Richard Sutton book, I've maybe made it up to like chapter 8, and I'm trying to get through the book because I feel like it's a huge like gap in my knowledge that I'm missing right now to really understand the whole landscape. But yeah, I mean, graph learning though is new, I feel like, and that's why it's so exciting, because it's like, I think at the ICML conference they had, or ICLR, they had like their workshops, and graph was the like graph learning thing. It was just the most interesting to me out of looking, like just going through their catalog of what they're publishing. So I'd say,
and like. By the way, like if I before talking to you and I would see a deep learning on graphs, I'd be like, okay, cool. I'll go and like I'll hang out with convolutional neural nets because they're familiar to me. Like, what did you know beforehand that made you take a like closer look at the graph learning?
I guess I've always been interested in the different like data modalities, like images, text, speech, but like I got started with machine learning before deep learning, and I think that it's a profound difference to understand. Like when I first got started, I had you're predicting the quality of a software based on these hand engineered features. So like somebody is saying like lines of code, I don't know, like indent blocks, like these kind of things. It's like describes the software. And then they have things like it's not quite the same as that, but like your microarray, your gene expression on your microarray to predict your, like how you're going to react to a drug. So I think just going from hand engineered data to like raw data is really interesting, in that it's interesting to actually.
And what do you mean? What do you mean? By, I'm not sure I understand the transition, and what does it mean to go from engineered data to like raw data? Could you
just like to take the images as an example, it would be like if instead of just giving my image to my convolutional network, if I like constructed some features, like they have like SIFT and HOG, which are like histogram of gradients and stuff. Like, it'd be like if I was like, this is the distribution of how the pixels fall. You know, good luck figuring out if it's a cat or a dog with that, but that would be like what that would look like.
Yeah.
It is a funny thing to think about. But I mean, they have these wildly clever ideas of constructing features from images. It's not like as dumb as that to just say that this is there's like 246 value pixels in the red channel, and like, you know, something like that.
And these are like non-deep learning ways to figure out whether it's a cat or a dog.
Right.
Okay.
They don't work like terribly. They work pretty well, actually. But yeah, not as well.
and like about the whole like graph thing, like what, and you were like talking about like what got you like interested before that you kind of took a look at the graph learning like graphs, and like what was it?
Well, before I actually even studied machine learning at all, I was pretty interested in like routing things, like just like, you know, GIS systems, like directions. So I guess maybe that made me really think about things like shortest path algorithms, and like really try to take it apart and like build it and make it run faster. So I mean, that just gave me a familiarity with the adjacency matrices and things like that. But the graph neural network, I think, is more interesting than that, because it's like the connections and then also features, sort of. And yes, I'd say probably the shortest path algorithms. Like, I think it's useful to have like a foundation of computer science. You shouldn't just like, I don't know, they're kind of tangent. I don't know. Maybe I have a foundation in computer science, so I started in computer science.
Yeah, it kind of makes sense. Finding like the shortest route and giving like the best recommendation on Twitter, and like it's kind of like the shortest route, but it's like the shortest route where you need that piece of like artificial intelligence that will learn like certain patterns of like what tweets you like or what tweets are valuable to you, and the same like with YouTube. And yeah, it makes like a lot of sense. And you've also started like, I guess you've been writing for a long time on like towards data science, maybe like other places probably.
Cool.
Yeah, and now you've started your YouTube channel, Henry AI Labs, which is named after your dog. I've learned that, you know. Just clearing up the confusion from people who are also going to be like, why is it Henry AI Labs?
Right. Well, I wanted to.
But dogs are awesome, by the way. I also love dogs.
Yeah, they are. I don't know. I wanted to build, like, I didn't want to build it around myself, because I do already have the towards data science thing that I'm pretty like interested in doing. I try nowadays though. I don't try to just like post on towards data science unless I have something that is like, I think is worth like really high level thing. So it's like YouTube is giving me like that daily blogging outlet, because it just motivates me to get through reading papers if I'm going to produce something and then hopefully get some kind of reward from it, you know, like just a response, I suppose. Yeah. It just helps you like study, I guess, in like, you know, this 2019 era we live in. If I can give myself more positive feedback to make myself study, I'm going to do it. Like, Yeah.
I mean, I 100% like agree with that. I mean, like on my channel, I don't cover like really as much of like deep things and like smart things as you are. I'm like more about practical application because that's for now what I can do. But like I noticed that when I try to reproduce, like when I try to teach something, like I understand that I did not understand the thing as well
right,
beforehand, you know. And how long does it take to produce a video? Because you're like uploading like one every like other day or like every day almost.
A video for me is a lot easier than to write an article because I'm so like I like worry about my like how the writing reads. Like, is it like a good narrative? You know, does it flow? All these like things that like an English major might care about. But with a video, I just like talk about it. I don't really have to worry about the aesthetic of it, if that makes sense.
Yeah, of course. I guess, and I'm gonna like go a bit, you know, to a different topic. When you were starting with like deep learning, what were like your initial like inspirations in the project that you were like building? Have you like jumped straight into something with like computer vision and then into GANs, or like what was like those first steps?
Yeah, so first I did the Andrew Ang course for a course in my college. And so after that, I was convinced I could build anything. You know, it's like the course is pretty good, I'd say. So then I tried to build like a basketball highlight detector. So you take like a full basketball game, and then you use the computer vision to turn it into a highlight reel. And that proved to be really difficult. But I mean, I tried at it for a while, and I definitely
and like, how did you try to do it? Did you try to like classify each frame with like a Conv net or something?
Well, I tried to break it up into 3 pieces. So first I tried to do the bounding box detector on the rim. So it's like, let's just look at the rim. It's like I manually encoded intention into it. Like, rather than letting it figure out attention, I did the bounding box and I said, look here, look at the rim. Like, don't look anywhere else. And then I just tried to construct a labeled data set of like the balls in the basket versus the balls not in the basket. And with that, you come into like one of the things that kills that more than anything is like false positives, because it's a class imbalance data set, and that's and that was a problem. And then in addition to that, it's something that I think I would have an easier time doing now, but back then I really struggled to figure out, okay, so I have my CNN features, how do I process this so that an LSTM can read it as a sequence, you know? And then just constructing the data sets is like a brutal task. It really is, like, especially
I mean with basketball and with video, like there are like so many frames there. Yeah, right. and what did you want to do then? Like I guess like what did you like do then?
I mean, that
with like the project.
After that failed, it failed in a pretty spectacular way, because I had tried to like go to pitch competitions with it and try to like really push it towards a lot of people. And so when I gave up on it, it was, maybe I shouldn't have given up on it, but it did kind of die in a spectacular way. So then after that, I just wanted to like really strengthen my understanding of the technology, so that before I jump into another project, I'll have a better sense of the landscape and what's doable and what's not doable. So yeah, that kind of takes me to where I am now. Just trying to just understand it all better before building stuff.
Yeah. I can feel like in the end, instead of making a system to capture the highlights, you'd make like a robot with computer vision that can process multiple frames, and it'll make the highlights themselves. because when your robot makes the highlights, you don't have to classify them. The robot knows that. So I mean, this is like the future of what's going to be happening. I mean, one thing that I want to also to chat with you, and this is kind of what I've been like figuring out for myself, because right now with the conv nets, I'm kind of at the level where I'm comfortable like building and deploying like traditional conv nets, but when it like comes to the realm of like res nets and inception nets, I'm kind of getting a little bit confused, like what should I be tackling first, like what are like the specific advantages of like using a res net versus like an inception net. Could you like give like your overview of convolutional architectures, and what do you think like they're, yeah.
I mean, firstly, I really need to be making more like videos around programming, but I use the Keras framework, and I know like people in my
I do too, by the way, like it's super good.
Yeah, people in my research lab like the PyTorch framework, and I'm trying to move towards that, but I love the Keras framework. It does everything that I've so far needed it to do. And even things with the graph convolutions, you can import the TensorFlow backend, and you just implement your own layers using like k.mean, k.subtract, and that works really well. But so for advanced convolutional architectures, I'd start to use the Keras functional API rather, like, you know how you would be like model equals sequential.
You mean like when you are not just making like model at sequential kind of thing, right? But like at the end of each layer you have like that little input in brackets, and you specify which layer gets which input, like that sort of thing.
Exactly.
Like,
exactly. Yeah. I understand what you're saying.
You got me.
Yeah, because you can implement like skip connections and the inception like splitting of feeding the same input to different layers by just being like, you know, x1 equals this layer, and then x2 equals take x1, x3 equals take x1 as input, x4 equals take x1 as input, and then x5 take them all as input. You know, it's as easy as that.
I'm gonna stop for a second, and I'm just gonna say like that's cool. I was afraid that I wouldn't be able to do all of that in Keras, but now you're saying that like it's possible. I just got a second charge of like encouragement to go and try to implement some of that in Keras. But before I do, could you continue talking about what's going on with the architectures?
Like from a theoretical perspective, or like how you would build it from the theoretical aspect of it?
Yeah, I mean, I guess, yeah, from the theoretical, because the building it is kind of like the whole different animal. So let's go with
I shouldn't even say
what works for what, you know.
Like a theoretical explanation would be if I said that they theorize that with the skip connections on the ResNet, you don't have to learn identity mappings theoretically, and that you're just building on features through that mechanism. But like, just to describe it like empirically, I don't even know why I said theoretically, but like they are using these designs to outperform the standard way of just being like layer. You know, like they have things like
and then you have like one layer like connected to this guy, like not just sequential, but kind of like this weird, you know, thingies.
Yeah, so I mean, like rather than try to give some explanation of it, I'll just leave it at empirically. This is what's working. Like doing the skipping and all that's what seems to work. The neural, I recently posted a video and I just read really got into the neural architecture search paper by like Kwok Lee. That paper is crazy. Like in addition, they search for like activation functions, they search for data augmentations and also optimizers. But designing the layer it's amazing, really. I mean, it would be hard to replicate because they have like 500 GPUs that they run for 4 days, but you could still like set up the search space yourself and then just do a random search. You're not going to...
And when you mean like designing a layer, you mean like picking out the amount of convolutional filters, or like in dense layers, like the amount of neurons?
No, this would be like a hyperparameter. That's like on the surface level, but they're really inside the network. Like they're taking apart what it means to be a layer, and then they're discretizing the ways that you can design a layer, and then they apply a search algorithm. Like you could use evolutionary search to like search through the discrete space of what a layer really is made of.
Yeah, by the way, I've seen that I've seen that video, but I didn't like go deep into thinking like what's like really going on with the search. But for instance, as a like rule of thumb, say if I wanted to classify an object right now and say like a pen, would I be better off, like, and from like purely, rule of thumb or something, would I be better off like going with an inception net right now, or like a res net, or something else? Like, what I guess works now best, my question is.
Well, I think for something like a pen, you could probably whichever architecture you pick, the best practice would be to then ensemble them, to have several of them trained on different slices of the data. And then it depends on if you need real-time detection.
And like, why is that? Why are like different? Why train several on different types of data?
I mean, why, I'm not sure, but that's always, why, I'm not sure, but like with all the past, like the Netflix recommendation thing, it's like ensembles of models they perform better. I have no idea why, but that's how it is.
Okay. But what was interesting is that you paused for a second and you were like, for this specific problem. So I guess I'd rephrase my question to like, just in the most general way, for say like a ResNet, a traditional like deep convolutional neural network, and for an inception net, what kind of problems are like best suited for solving?
I'm not sure if this is totally correct, but to me it seems like once you start...
Yeah, of course, like it's from your experience, from what you observed.
Once you start to have a really large number of classes, so like how ImageNet has like, I don't know, like 1,000 classes. I've seen like the way that they do like skin cancer detection is they structure the space like hierarchically. So it's like a tree. So you predict like these types of high level cancers, and then you would go to the leaf nodes and predict a more specific cancer. So it's like when you have a lot of classes, you need to think about how you're structuring your output space. And then it's just such a complex problem that I think that this is when you really need to use the state of the art for something like just image classification. But that's just what I think. I'm not sure if that's even correct.
And like what is what is the state of the art for solving those complex problems, I guess?
For image classification, I bet it's something like the neural architecture search layer paired with the auto augment data augmentation, and then maybe obviously like trained on ImageNet and then probably transferred to some other task, I imagine would work. Although I've read studies that say that doesn't actually make it perform better, it just makes it converge faster. So it's more so that it just speeds up but then again, if it converges faster, now you can do like these surface level hyperparameter optimizations, which is going to make you find a better model. So yeah, I guess, I'd say that just things like that. I think once AutoML and like meta learning can design the whole network, which I think is a very far off thing, that's that's what'll be the best convolutional network.
The state of the art thing. But I guess I guess like that's sort of like. What's the most complex problem in like with deep learning, maybe like with GANs or with just classification like Conv nets that you kind of took on and try to like solve with maybe like fellow researchers, or just what was like the hardest task that you took on?
Probably just trying to figure. The hardest, like to define the task as hard, would be like trying to make the GAN data work for data augmentation, because it was so hard that it never worked. That's how I would define it.
Yeah. You mean like for augmenting the data for classifiers, like that thing that like didn't work? Yeah. But I guess maybe I should like rephrase. What was the problem that was in the intersection of being both like hard and exciting at like the same time? Cause if it's hard, I guess like we've all been there, like solving something that's just crazy and not that fun, just rigorous or tedious.
I mean, most of what I've looked into might not be super interesting to like software developers who are very like application focused, because I look into just like trying to make it work in some problem I find interesting. But like two things that I've looked into are super resolution CNNs, where you try to take like a 32 by 32 and upsample it to like 128, and that's fascinating. Like I'd say that was interesting. And then another thing would be,
and did it work? Did it like were able to produce some results?
Yeah, it did work. Yeah. Especially when you add the adversarial loss from the GAN to it. It's actually really cool to see that. They have like, I'm not sure if these web apps where you can go super resolve your picture actually uses like GANs and deep learning, but it would work. And then
you know, like we could literally like say take like your face that I see on my screen like in 100 by 100 pixels, or I guess like in your case it was like 30, so we could take like a nest image that was like pretty close, like 20 by 20, we could like upsample it to 34, or like what was it, like with 128.
Well, what I did is I just scraped images from the web, like sneaker images, just because it was fun, I guess. Just arbitrarily chosen, really. And then so one other thing I looked at was trying to do sentiment classification from images, because like sentiment classification in text works really well, and so it was curious to see like, does it work for images as well? Like it's like if I show you like a bloody picture of like some horror movie, this is highly negative, and then it's like if I show you like a puppy, is highly positive. So to see if the CNN can learn that kind of feature, that was something that I worked on, that ended up getting around like 81% accuracy on like 15,000 images. And that was something that I thought was super interesting, because it's not just learning like ears and nose, you know, it's learning like what's happening in the picture, sort of, to some level.
It's like the feel, like it's almost like that trying to I guess the data was labeled. It was kind of trying to like replicate that human feel of how would a human being classify an image. So we've hit 45 minutes. Do you have some time to keep going, or should we wrap up?
I'm sorry, I was just about to mention that. Well, thank you so much. I hope.
Yeah, thank you so much, man. It's been lots of fun. Really glad we. Do you want to like say some like final words here? Some words into the internet.
Like, thanks for listening to me talk on the show. I hope that you come and check out Henry AI Labs and see some of my YouTube videos. I hope to be back on this at some point, and hope to see that this grow and reach a bigger audience as more people like connect to try to understand deep learning and catch up with the research that's out there. All right, thank you.
Beautiful, man. Thank you so much.
Thank you.
Bye.
Bye.